Now, the law of large numbers. As the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. Now, Jacob Bernoulli, a major contributor to the field of probability, believed that the law of large numbers was common sense. This is evident in the following quote from his text, Ars Conjectandi. For even the most stupid of men, by some instinct of nature, by himself and without any instruction, is convinced that the more observations have been made, the less danger there is of wandering from one's goal. Okay, so now we're going to take a look at an applet. Okay, and this is going to talk about our activity 1, the law of large numbers. So here we're opening up the applet where we're rolling one die with 10 sides. So we're going to simulate rolling a 10-sided die 30 times by pressing 5 runs 6 times. And then be sure that outcomes is selected by verifying it is highlighted in gray. So it is highlighted in gray, and you can see here we go back and it's highlighted in gray. And now what we're going to do is we're going to select the equal sign, and then we're going to change the entry box to be 4. Okay, and so now let's go ahead and do this. So 1, 2, 3, 4, 5, and then 6. So it says what proportion of the 30 rolls resulted in a 4? Well, we had 2 here out of the 30, which the proportion is 0.0667. Okay, now let's scroll down a little further, and now we're going to go to part B. We're going to reset the applet. So we're going to reset the applet, and now we're going to simulate it again, doing the 10-sided die 30 times by pressing 5 runs 6 times, making sure the outcomes is gray here. We have the equal sign, and we're going to leave the 4. So let's go ahead and do this 6 times. 1, 2, 3, 4, 5, 6. Okay, so what does the result tell us? Well, the results from part B are likely not the same as those for part A. And why is that? Well, this is due to the fact that parts A and B are 2 different random processes with different outcomes. Okay, so now we're going to move to part C. Part C, it says to reset the applet, and now we're going to click on convergence and make sure that's highlighted in gray. And then we're going to simulate rolling a 10-sided die 2,000 times by pressing 1,000 runs twice. Okay, now watch the applet carefully to see the convergence. Okay, so we're going to click this twice. Okay, now, what proportion of the 2,000 rolls resulted in a 4? Well, you may want to click the outcomes to see the proportion of the rolls that resulted in a 4. Well, here's the count. If we go to outcomes, you're going to see that we have 196 out of 2,000, which gives a proportion of 0.098. Okay? Now, let's take a look at the last part, part D here. Okay, we're going to click Reset of the Applet. We're going to click on Convergence to make sure it's highlighted in gray. And then it says Simulate rolling a 10-sided die 2,000 times by pressing 1,000 runs twice. Okay, now again, let's watch the applet carefully to see the convergence. So there's our first, and there's our second run. Okay, now, is the behavior in a short run fewer rolls of the die the same as it was for the first 2,000 rolls? Well, is that the same? Okay, you can look here that the proportion is different. If we go to the outcomes, right, we can see that we have 208 out of 2,000, which is 0.104. So what does the proportion of rolls that resulted in a 4 converge to in both part C and part D? Well, that is, what is the probability of rolling a 4 with a 10-sided die? Well, this illustrates the law of large numbers. Recall, this law states that as the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome.